So we're going to look at some different ways to graph linear equations, and you can see that we have three different types of equations here in different formats. So we're going to see how to graph all of those. So the first one is in y equals mx plus b format. So when we have this format, b represents our y-intercept. And for this particular example, we have b equals -4. And m represents our slope, which is rise over run. And for this one, we have 1/3. And so the first thing we plot is our y-intercept, and that's going to be at -4. And using the slope, we go from the y-intercept up 1 and over 3. And those 2 points are enough for us to draw a line, but if we want a more accurate line, we can add more points by continuing to go up 1 and over 3. And so we have another point here. And if we want to go backwards, we could go the opposite for both the rise and the run. So we would go down 1 and backwards, or to the left. So then connecting those dots, we have our line for y equals 1/3 x minus 4. For example 2, we could certainly rearrange this so that we have the same format, the y equals mx plus b, and we would get y equals 2/3 x minus 4. But instead, we're going to look at a way that is a little bit faster. And that is to find the two intercepts. So by plugging in 0 for y, that cancels, and we have 2x equals 12, and we divide both sides by 2. The 2's cancel, and we have x equals 6. So that means we have a point at 6, 0. And for the y-intercept, we plug in 0 for x, and this time that cancels. -3y equals 12, and we divide both sides by -3. We get y equals -4, and we have 0, -4 as our other point. So we place our 2 points on the graph, and there's our line for 2x minus 3y equals 12. So for the third example, we don't have any special format at all. We just have all these x's and y's and numbers, and so we need to just rearrange it. And we can change it either to y equals mx plus b or to ax plus by equals c. So for this case, I'm going to go ahead and do the ax plus by equals c. So that means I'm going to want to get all the x's and y's on one side of the equation and the numbers on the other side. So I'm subtracting this y on both sides of the equation, and I'm also going to distribute this 3 to get rid of those parentheses. So my 2y minus y gives me 1y minus 1 equals, and then 3 times -5x, -15x, 3 times 2 is 6. And now I'm going to bring the 1 to this side by adding 1 to both sides, and I'm going to add 15x to both sides. And so now I have 1y plus 15x equals 7. So now that we have ax plus by equals c, we'll find our two intercepts. So by plugging in y equals 0, I found that x equals 7/15. So we have a point at 7/15, comma 0. And 7/15 is pretty close to 7/14, so we can say it's pretty close to 1/2. So we have our first point. And for the y-intercept, we plug in x equals 0. And this is supposed to be a plus here. So the 15 times 0 cancels, and we get y equals 7. And so we have another point at 0, 7. That is here. And so here's our line for this equation. And if we wanted to know the slope, of course, we could count down, which is a rise of -14 over the run. We always go left to right for the run, and the run is 1. And it looks like our y-intercept is at 7. So if we were curious about the y equals mx+b format for this line, we know that m equals -14 and b equals 7. So it would be y equals -14x plus 7. So before we're totally finished, let's just take a look at how it would have worked if we had tried to get y equals mx+b format in the first place. So we would have wanted to move all of the y's to one side of the equation and everything else to the other side. So we still would have started by subtracting this y from both sides and distributing the 3. So then we get y minus 1 equals -15x plus 6, and then we're going to add this 1 to both sides, and we end up with y equals -15x plus 7. So why did we get -14 down here instead of -15? Well, that's because we counted the rise and the run just by looking at the graph. But some of these points on the graph might not be exact. So even though it looks like there's a point here at +1, -7, it's in fact a little bit off since this point here was not exactly at 1/2. So in order to find the exact y equals mx+b, we have to calculate it.